Bar graphs. Let's review. Frequency tables are a way to organize data or information. Here's an example of a frequency table. Let's review the parts of a frequency table. This is the title, favorite sport. It tells me what this data is about. These are the categories. They're kind of like the answer choices. So when I ask, what's your favorite sport? The categories or answer choices were soccer, football, basketball, baseball, and volleyball. These are tally marks. They're an easy way to count the number of people who chose each sport because they group them together in 5. So for soccer, I don't have to count 1, 2, 3, 4, 5, 6. I can just count 5 and then 6. We can use the data in this frequency table to create a bar graph. Bar graphs are another way to organize data. A bar graph also has a title. The title here is still favorite sport. And it has categories, which remember are like the answer choices. Soccer, football, basketball, these are the sports that they had to choose from. To make a bar graph, shade in the bars to show the amount. You can see on the left of the graph the number of people. So for soccer, that was 6 people. So I'm going to shade in a bar reaching all the way up to the number 6, like this. For football, I'll shade in 4 because 4 people liked football. You can see that the yellow bar reaches up to the line next to the number 4. It also fills 4 of the sections in the graph. Basketball, there were 3 people. Baseball had 8 and volleyball only had 2. The data shown in this bar graph is called categorical data because the categories or answer choices are words: soccer, football, basketball, baseball, volleyball. The data shown in this bar graph is called numerical data because the categories or answer choices are numbers. This graph shows the length of pencils in inches. So the categories are 4 inches, 5 inches, 6 inches, 7 inches, 8 inches. The categories are numbers, so this is called numerical data. Let's take a look at the types of questions you may have to answer when interpreting categorical data. We'll use our favorite sport graph for this. Here's the first question. How many people chose football as their favorite sport? So let's look at football on our graph. And I love bar graphs because they're very visual. Here I can see football, and I can see that the yellow bar above football reaches up to the number 4. And that means that 4 people chose football. How many people chose either soccer or basketball? When you see a question like this, either or, it means you need to add together the people who chose soccer and the people who chose basketball. 6 plus 3 is 9. 9 people chose either soccer or basketball. How many more people chose football than volleyball? How many more? Those are subtraction words. So let's look at how many chose football, 4, and how many chose volleyball, 2. What is the difference between 4 and 2? 4 minus 2 is 2. 2 more people chose football than volleyball. And you can see this clearly on a bar graph. You can see that football has 2 more little sections shaded in than volleyball. What was the most common favorite sport? This is also very visual. Without counting anything or looking at any numbers, I can see by looking at this graph that baseball has the most shaded in. It has the tallest bar, and that means that baseball was the most common sport or the one that was picked the most often. What was the least common favorite sport? Same thing, except the shortest bar. Volleyball has the shortest bar. It has the least shaded in. It was the least common or the one chosen the least often. Now let's look at the types of questions you may have to answer when interpreting numerical data, and these can be a little bit trickier. How many pencils measured 5 inches long? Same as with categorical, go to 5 inches and see how high up the bar goes. It goes to the 6. So 6 pencils measured 5 inches long. That one's pretty easy. How many pencils measured longer than 5 inches? So that means 6 inches, 7 inches, and 8 inches. All of those measurements are longer than 5 inches. That's 2, 4, and none of them measured 8. So let's add them all together. 2 plus 4 plus 0 is 6 pencils. 6 of these pencils were longer than 5 inches. How many pencils measured 6 inches or less? This is a slightly different type of question. This time, I want the pencils that measured 6 inches, but I also want the pencils that measured less than 6 inches, the 4-inch and 5-inch pencils. So I need to add together the 4-inch, 5-inch, and 6-inch pencils. 2 pencils measured 6 inches, 6 pencils measured 5 inches, and 4 pencils measured 4 inches. And when I add all those together, I get 12 pencils. 12 pencils measured 6 inches or less. How many total pencils were measured? So here I just need to count all of the pencils that were shaded in. That's 4 4-inchers, 6 5-inchers, we got 2 6-inchers, 4 7-inchers, and no 8-inch pencils. And when I add all those together, I get a total of 16 pencils that were measured in order to make this graph. What was the length of the shortest pencil? Now, you may be tempted to say 6 inches because it has a very short bar, or 8 inches because it doesn't even have a bar. But we're not looking at the bars for this one. We're actually looking at the inches, the lengths. These are across the bottom here. Which of these lengths is the shortest? 4 inches. 4 inches is shorter than 5, 6, 7, or 8 inches. It's the shortest length. So the pencil with the shortest length was 4 inches long. What was the length of the longest pencil? Once again, we're looking at the lengths, the inches along the bottom, and you're probably going to want to say 8 inches because that's longer than 4, 5, 6, or 7. But be careful here. Look, did any pencils actually measure 8 inches? No. So really, 7 inches was the longest pencil that was actually measured, 7 inches long. What was the difference in length between the longest pencil and the shortest pencil? Well, the longest pencil was 7 inches, and the shortest we know was 4 inches, and we're asked to find the difference. That means we need to subtract. 7 minus 4 is 3 inches. The longest pencil was 3 inches longer than the shortest pencil. What do you notice about this bar graph? Take a look at the numbers along the side here. This is called a scaled bar graph. In a scaled bar graph, the numbers along the side do not go up by 1. They skip count by 2 or 5 or whatever. In this example, they're going up by 2. 2, 4, 6, 8, 10, 12, 14, 16. We have to be extra careful when answering questions about a scaled bar graph. Take a look at this one. How many people chose cat as their favorite animal? Well, you might be tempted to say, looking at this bar, 5, because 5 sections are filled in, but that's not correct. Take a look over at the numbers on the side, the number of people. This bar actually reaches up to 10. 10 people chose cat, and that's because each of the sections are actually worth 2. Let's switch the scale up again. Remember, always pay attention to the numbers along the side. This time, the number of people is going 0, 5, 10, 15, 20, 25, 30, 35, 40. We're counting by 5s here, and that is going to change our answer. Now, how many people chose cat as their favorite? Well, once again, you may be tempted to say 5, but you need to look over to see what number it lines up with. It lines up with 25. 25 people chose cat. and that's because this is a scaled bar graph, where it doesn't count by ones. This one is counting by fives. Let's review. Bar graphs are a visual way to keep track of and organize data. Data can be categorical, words, or numerical, numbers. Some bar graphs are scaled, and the numbers don't increase by 1. They might count by 2s or 5s or 10s or even 100. This video was created by La Fontaine of Knowledge. Click the link in the description for lesson materials that go along with the video, and subscribe to my channel for more videos like this.